Oh, sorry. Yeah, it happens. All right, guys. So today we're gonna talk about solving. Okay, I can bring it down a little bit. All right, we're gonna talk about solving rational equations with rational expressions in them. Okay. Two things I want to share with you before we begin. You don't need to write this, but I would like you guys to watch. We've talked about how to deal with fractions in here before when we're trying to solve equations. Do you guys remember what we need to do to solve that? There you go. So we find we don't like the bottom number, right? So what we do is we multiply the fraction by that bottom number, right? So that way it cancels it out. But with equations and with fractions, if you do it to one part, you have to do it to all of them. So you would do it here, and you would also do it here. So those cancel also. And now you no longer have 3 times 1 is 3. You no longer have fractions. So we're going to be doing that today when you're solving these equations. You're going to be multiplying everything by the denominators so that you get a nice looking equation that's not as nasty.
What if they don't have the common denominator?
Then you might have, so Josh is asking, what if this was like 2/3 x plus 1 is equal to 5 over 7? What if they weren't the same, right? So you would just do it once for the 3 and then simplify it. And when you're done, do it again for the 7. Yeah. All right, good question. The next thing I wanted to point out was, what can you not have on the bottom of a fraction? 0. So if you're not allowed to have the bottom of your fraction be 0, what is x not allowed to equal for this? 1. Because if it was 1, the bottom would be 0, right? Okay. So those are some things that we're going to be keeping in mind today as we do our lesson. So let's go ahead and jump in and do this thing. All right, I can tell you guys are trying. I appreciate it. You're doing great. I hope, and I'm not doing it for me, I'm doing it for you. So I hope it helps you guys too. Go ahead and write down example 1 here. Where's my... I'll pause. Hello. Okay, so I want to get rid of 3n squared, I want to get rid of n squared, and I want to get rid of n. Which one should I multiply by to get rid of most? 3n squared. You want to multiply by the one that's bigger, right? Because that's going to cancel out more stuff. So what we're going to do is we're going to put 3n squared. I'm going to put this one up here because I don't really have the room to squeeze it in. We're going to multiply 3n squared by all 3 of these parts. So multiply it times the first, the second, and the third fraction. Now in the first fraction, it just goes away completely and leaves you with 2. The next one, only the n squareds cancel, right? The 3 is still there. So I'm going to put that 3 in front of the n plus 6 so I remember to distribute that. And then for the last one, we can actually reduce that also. If I reduce that into n squared, it will take one of the n's away, leaving me with just n to the first. So now I've got 2 times 3n. So at this point, we don't have to multiply anymore. All the fractions are gone, and we're ready to just start simplifying. So here we go. Distribute. Multiply. 2 and 18, you can put those together to make 20. And then minus the 3n. And then divide. Yeah, so a lot of these will come out to be fractions, but that's not too uncommon. You guys got any questions here about that? Yeah?
Do we need to put them in decimal place, or can we just leave it in a fraction form?
Leave it as a fraction. That's how it'll be on your guys' test.
Okay.
Yeah. All right, now there's something I want to talk to you guys about. rational expressions can sometimes, even though you do all the math right and you get an answer, you can sometimes end up with a false answer. It's called an extraneous solution, okay? Remember I told you fractions can't have 0 in the bottom? So what value of n would make this denominator equal 0? 0. So n is not allowed to equal 0. So let's put that on there. Well, so yes and no. So here's the thing. So Josh's question was, is that necessary? And the answer is yes and no. So here's the thing. In this problem, it seems like it's not even necessary. What's my answer? 20 over 3. Is that n equals 0?
No.
No. So that's a good answer. But here's my point. Every time, and it happens very rarely, but every time you solve these, you should always go back and make sure that that answer does not make the bottoms equal 0. If it does, then that's what we call an extraneous solution. Okay, and we throw it out. A good hint about when you should probably check to see if your answer, you should always do it technically, but definitely if you're on a multiple choice test and one of the answers say no solution, even though your answer's there, you might want to make sure it doesn't make the bottom equal 0. Because if it does, then that's like they're trying to trick you, because the answer is really not your answer, it's the no solution because it makes the bottom equal 0. Does that make sense?
Yeah.
So just watch out for that. And I'm going to check it every time. And honestly, I did the homework and I did this, and I'm not seeing it happen at all. But I know when I make the test, it's going to be on there somewhere. So I want to keep emphasizing it. I don't know, I just know, but luck would have it. Like that'll be the one time it pops up. The software makes the question. So sometimes it's there and sometimes it's not. It's a pretty rare occurrence, but it can happen. All right. So before I let you guys practice, I want to do another one with you real quick. Go ahead and write down this one, example 2. Okay, so I hope you guys notice this one looks a little bit different, right? Now the question is, what is different about this? Good, nice, good. You're 2 steps ahead of me. So the thing that stands out that's different is that this is not just like a monomial, it's a binomial. And now that we have that, the question is, what do we do with that? Well, the answer is you want to factor it, okay? So let's do that. So this one has a GCF, and that GCF is P. So I'm going to take out a P. I'll tell you why we want to do that in just a second. But the point here is factor if you can. The one over here on the right does not factor, so I'm going to leave it. So here's why. Remember when we were getting a common denominator when we're adding and subtracting rational expressions? We factored the denominators so that we didn't have to multiply by too much and end up with something that was too big and confusing. Same thing here. If you don't factor it, you're going to over multiply and you're going to end up with polynomials that are really hard to solve. So the first thing you want to do then is, if you can, factor the denominator. Now we start multiplying, okay? So what should I multiply by to cancel out the most stuff? P minus 4 and P. So this whole thing, do that whole thing. Because if I multiply everything by that, it's going to cancel there. It's going to cancel here. And over here, everything won't cancel, but the bottom will be completely gone. What cancels on this one? That goes away, right? So what's left here then? 1. What's left here? P plus 1. And here, and we can solve it from there, right? So that's it. I'm going to combine my like terms. Put those P's together. And then divide. So I get P equals 2/5. Okay, now looking at the original one's a little bit confusing. It's easier to look at the factored form. So what can P not equal? can't equal 4, because if p equals 4, then this becomes 0, right? And 0 times anything is going to be 0, right? But there's actually something else that p can't equal. Does anybody know? It can't equal 0. Because if p is 0, then I have 0 times this, right? And that'll be 0 also. So in this case, p cannot be either one of these. But is that my answer? No. So this is a good answer to keep. And like I said, I don't think we're going to come across one that comes out to be an extraneous solution, but they do pop up. And so I will keep checking it just so you guys get used to the habit. But I think we're ready for a student practice here. So I'm going to write this one down here real quick. This one is one of the harder ones where you have to factor it. So if you want to start with a harder one, you can. But I'll also put one up that's more like the first one I did. Right there. So we'll call this student practice 1 here. And we'll call this 2. All right, so go ahead and try both of those and see what you guys get. I'm going to move on here. So first thing I want to say is that the top, you should have gotten negative 3 over 2. Bottom, you should have gotten n equals 1. Now here's the thing. The most common mistake is the one I don't want you guys to do anymore. Okay, you ready? It's that very few people started number 2 the way they were supposed to. Very few people. A lot of people started just right away by multiplying. You don't do that. What do you do first on number 2? Factor first. That's the thing you guys forgot. So here we have n squared minus 4. We should have rewritten those as n plus 2 and n minus 2.
To be fair, even if you don't multiply, you still end up
So when you do that, let me show you what happens. Now I'm going to multiply everything by those bottom numbers, n plus 2 and minus 2. Okay, now here, these go away. And what are you left with? 1. Same thing here. These go away, and I'm left with 2. But here, something else happens. The n plus 2's go away, but I'm left with a 1 being multiplied by an n minus 2. And so that's from there, I'm not going to finish it, but you guys have the idea at that point. So factor first. Yes? Okay, give me a second. I will. All right. We did that one. Thank you. We did that one. Thank you. We didn't do that. All right, so go ahead and write down number 5. Okay. So we did good that first time, and these are hard questions. These are hard questions, but I don't know. Did you guys find that the quiet helped a little bit?
No. I didn't like it. My headache is.
Who said they didn't like it?
I didn't like it.
Really? These are weirdos. All right, so I'm going to call on somebody here, and I want them to tell me.
Wait, what is this?
What I do first. This is example 3, I think we're on now. So, Alan, it's on you, bud. If you don't get this right, I'll cry. I'll break down right here. So, Alan, what is the first step? You factor the denominator. Good job. I don't have to cry. He's right. So let's begin by factoring the denominator. So now if I factor this denominator, that's a GCF problem. Okay, it's not a difference of squares because there's an a here. So I'm going to take out an a, and now I have that. Put your binomials in parentheses, right? This one needs to be factored as well. So it's also a minus 4. Okay, after you factor, then you begin the multiplication process, right? Now I want you guys to be ready because this probably something different does happen. It doesn't happen yet, but we'll get there. It happens in the solving process. All right, so we're going to multiply everything by a and a minus 4, right? So let's do that. Okay. Now on this fraction, everything goes away except the 1. On this fraction, what goes away?
Just the A.
Just the A. What I'm left with then is I'm left with one binomial, the a minus 4, being multiplied by the other binomial, which is a minus 6. That's part of the new one right there. Okay, the last one here, everything here goes away with everything here. But keep those parentheses. Yeah.
So do we factor the a minus 4 and the a minus 6 with box method?
We're going to multiply.
Okay, you can go.
So, we would multiply this, you guys. He's had it with the class. He's gone. All right. So we're going to multiply this with the box method. I'm not going to show my work for that. I'm assuming you guys are pretty decent with that by now. But if we multiply that out with the box, we have a squared minus 10a plus 24. Okay?
Actually, just he actually just left.
Well, he always has for his leg.
Wait, but he usually waits.
Distribute the negative?
Like that British accent.
Yeah, right?
Yeah.
And that
Okay, so we're shouting out again. I'm getting a little distracted. But here we go. So we're going to distribute here. So that's going to give us minus a and plus 1. And now we're going to combine our like terms. So I have 1 equals, the a squared has no like terms.
Negative 11a.
Good. The 10a
And then
and the negative a
24.
makes negative 11a. And then the 24 and the 1 makes 25. Okay, now here's where the difference is at. We haven't dealt with this yet. That's not a regular equation. That's a quadratic equation. So, when you see one of these quadratics, I'm going to tell you guys the 2 steps you're going to do to solve it. You ready? Move everything to one side so it equals 0. That's step 1. Move everything to one side so it equals 0, and then you're going to factor it to solve it. Okay? So move everything to one side and factor it. Ready?
what, we don't
One
do
side.
fully color? Okay.
You could use the quadratic formula as well. It's just that I find that this will probably be a little bit cleaner for most students, but you can do it if you like quadratic formula. So I've done my first step. I've moved everything to one side so it equals 0 now, right? Now we factor it.
Okay.
I will review the factoring with you. So the first term goes up here. Last term goes here. We're looking for 2 things that multiply together to make a squared, and 2 things that multiply together to make 24 that make 11. What would that be?
8 and 3.
It would be 8 and 3, and they're both negatives, right? Okay, so now I have this. A minus 8 times a minus 3. So I've moved everything to one side. I factor it. You guys know what to do from here? Set them all equal to 0 and solve, right? And that's it. So that's the only difference. We have a minus 8 equals 0. We have a minus 3 equals 0. And you're going to get 2 answers. When you have a quadratic, you'll very often end up with 2 answers. That's equals 8. And for this one, a equals 3. What are the 2 things that a is not allowed to equal over here? 0 and 4. Is that either my answers? Then those are my answers. Now here's the thing. Remember how I said like in a multiple choice test, if it says no solution, you really might want to check? With these, it's a little bit suckier because, for instance, they may have one answer be 8 and 3. They may have one answer be 3. The other answer 8, and the other one no solution. So the point is that it's possible that this one is an extraneous solution if it makes the bottom 0, but not this one. So you still have a solution. Does that make sense?
Yeah.
So be careful. But in this case, we have 2 solutions. It's 8 and 3. Yes, yes. All right, so if you can walk out of here doing this one. then you know what's going on. This is our last one for the day.